In today's video, I want to talk about Reflexion Framework, which enhances AI agents by equipping them with dynamic memory and self-reflection capabilities. So this allows agents to improve their reasoning skills over time. So let's try to break down how reflection works. So before we dive into reflection, it is very important to understand REACT, which is reasoning and acting, the foundation upon which reflection builds. And then let's talk about how REACT works. The first process is query input. This agent receives a task or question, and then its LLM responses. This large language model generates an action based on the query, and then its action execution. This agent performs the action in the environment, and then the environment feedbacks. So this environment will provide the observation or result. And the last is reward assessment, which is a reward model will give a binary reward, which is success or failure. Let's see a concrete example. Imagine an agent in a text-based game which is tasked with finding a hidden treasure. The query is finding the hidden treasure in the castle, and the LLM output is go to the castle gate. And the action is agent moves to the castle gate, and the environment observation is the gate is locked, so the LLM output is look for the key nearby, and the action is agent search for a key, and the environment observation is you find a golden key, and the LLM output is use this key to open the gate, and the action is agent open the gate, and then the environment observation is the gate is now open, so the reward is success. The agent is now proceeds toward finding the treasure. Now let's introduce to reflection, which enhance REACT with self-reflection. So reflection adds a heuristic function and self-reflection mechanism to the REACT framework. They have three key components. The first one is heuristic function, HT, which determines this agent trajectory is inefficient or contains some hallucinations. And then is self-reflection, which is this agent reflect on failed trajectories to improve the future actions. And the last one is working memory, which stores the inflection to inform the subsequent decisions. The heuristic function can detect inefficiencies and hallucinations. So first, let's talk about inefficient planning. The definition is when this agent takes too many steps without making any progress. So the detection is this heuristic notice that there's no trajectory without achieving the goal. So let's see a concrete example, which is this agent keep wandering in a castle corridors without finding any clue for after 20 steps. And the heuristic alerts is inefficient planning detected. Let's consider a new approach. And the second one is hallucination. The definition is when this agent repeats the same action again, but expecting different results. The detection is when this heuristic identifies repeated action, which will lead into identical observation. For a concrete example, the action like open the locked chest, but the observation is the chest is locked, which is repeats in 5 times. So the heuristic alert is the hallucination detected, but repeating the same actions again without progress. Now let's talk about self-reflection mechanism with learning from mistakes. When the heuristic function flags an issue, then this agent engages in self-reflection to adjust its strategy. The process is first, it collects failed trajectory. It gathers the sequence of actions and observation which lead into failure, and then it generates reflections, which is use the large language model to create a reflection that identifies mistakes and suggests to improvement, and then update the working memory, which is store up to 3 reflections to inform any future actions. So a failed trajectory example is action 1, open the locked chest, and observation 1, the chest is already locked, and it is repeated multiple times again. So the reflection generates is I repeated to open the chest without a key. So I should look for a key first, and then it updates the memory. So the reflection is stored for future references.